Every protein dreams of this day, the day they get to cross the unknown and fulfill their purpose. Thousands undergo the training, yet only few survive to go on and execute the mission. I'm only one of 2 in my class to have made it so far. I'm determined to be the one to make it to the other side of this rigorous and cruel cell membrane.
Child, before you begin your journey, I must explain to you what you will encounter. The cell membrane structure is complex, and many fail to navigate it. It is built up of a phospholipid bilayer. This means that there are 2 rows of phospholipids. The heads are hydrophilic, they love water, while the tails are hydrophobic, meaning that they fear it. This makes the phospholipid amphipathic, as it has a hydrophobic and a hydrophilic part. Between this layer are a variety of obstacles that may try and scare you away. Do not be fooled by them. I trust that you will make it through.
I won't let you down, O wise one. Whoa, those are gigantic. They're like a gazillion times bigger than me. Wait, are those a bunch of cells connected together?
Yes, we are. Oops, didn't mean to scare you. I'm just a singular cell. However, I am connected to thousands more, making us a junction. That basically is a complex of neighboring cells that provide structural support to one another and communicate with each other. We are anchored together using protein receptors on the extracellular surface of the membrane. These receptors bind to one another, allowing for anchorage to occur. When this happens numerous times, it creates a junction.
Oh, I guess that makes sense.
Yes, but I suggest you hurry along further down. The cell that you must enter is still a bit of a journey to go.
Who dares to enter our territory?
Hi?
You? You are so tiny. You'll get lost the second you enter.
No, I will make it through.
If you say so.
You shall never make it through.
Ah, what was that?
What? Could I have explained that I technically am a protein like them? Yes, but that's too much work to explain my beautiful chains of sugar. They allow me to talk and communicate with all the other cells, just like I'm designed for. How else do you think I get all the gossip?
Don't be taking all the credit. You know that without me, you have to interact with all the other cells by yourself. Every single one of them. But in all seriousness, the poor guy would have been confused. We basically did the same exact thing, except my carbohydrate chains are much better than yours, and they're attached to a lipid, but yours are to a protein.
Imagine if she had to hear about me as well. That would be a very tedious conversation, having to explain about how all 3 of us technically help with the communication with other cells. At least I have another role, unlike you. I get to control the fluidity of the cell membrane.
Who are you?
Hi, I'm Molly. I'm a molecule and I'm trying to travel across the membrane.
Me too. Do you want to stick together? This place is creepy.
Of course. Whoa, do you see that? It looks as if that thing is torturing the other thing.
Run before it's us.
Wait. Do not be afraid, little ones. It is I, Penny the peripheral protein. I am a protein that is loosely attached to the cell membrane, where I see you are trying to enter.
That's cool and all, but why are you basically attaching yourself to the blue blob?
That is because I am specifically an enzyme peripheral protein. I catalyze reactions on the surface of the cell membrane once the substrate fits from the active site, allowing the reaction to speed up. Each one of us has a different substrate, basically targeting a different reaction. I am a phospholipase A enzyme, allowing me to break down lipids as they approach the surface.
So you aren't trying to kidnap them and suck the life out of it?
Of course not. They are my friends. You, on the other hand?
It's okay, we're leaving.
What is that? Transmembrane proteins? That's interesting.
How about each of us go down one pathway and we can tell the other about the experience afterwards?
Wait, Molly, isn't the first rule about haunted houses to not split up? Molly? Okay, I guess I'm on my own now. Whoa, I'm in the cell. Molly, you're here.
Hi, Polly. I have so much to tell you. You know the tunnel I went through? It started talking. I was so scared. But now I think I understand everything about transmembrane proteins. But okay, first let's talk about integral proteins. They're basically proteins that are embedded within the membrane. There are a few subsections. However, one subcategory of them are transmembrane proteins. These are proteins that span across the phospholipid bilayer, allowing them to have a part sticking out on the extra and intracellular sides. Two common examples are protein pumps and protein channels. These are used to transfer molecules into and out of the cell. Fun fact, the whole purpose of a cell membrane is to control what leaves and enters the cell. Anyways, protein channels use passive transfer, meaning that they don't require energy. That's where I went, so it was super easy to get across. But where you went was the protein pump, which uses active transport. That means it needs energy, so it may have been a little bit difficult for you to get across.
Oh no, what's happening? Why is the cell suddenly starting to grow?
That's because signal transduction has just occurred.
Huh? What's that?
Don't tell me you don't know what that is. Basically, a protein, known as a ligand, binds itself to a receptor on the extracellular side. This causes a signal, or a message, to be passed along into the cell. This can cause many different reactions, such as cell growth, division, or even cell death. Anyways, clearly you guys don't know much about this place.
Well, we've never been here before.
Yeah, but welcome to the cell. But also, good luck navigating this place.
Adios, amigos.
Okay, this has been a crazy day. At least I had Molly, and at least we both survived the haunted membrane.